Hello, today we'll study about sequence stratigraphy. Uh, sea level change plays a major role in determining the sedimentary depositional pattern in an area, and that study uh, of sedimentary rocks with respect to sea level change is known as sequence stratigraphy. Now, here is a simple picture of an area showing a basin from land to the deeper sea part. In any area, suppose in area B, which is an intermediate portion between the higher sea level, which is known as high stand, that is when sea level is high, mean sea level, that is the mean sea level is higher than the normal uh, present day sea level, and sometimes the sea level is lower than the point B, that is the low stand, that is when sea level is lower than the present day sea level. We take the present day mean sea level as the standard value of sea level uh, height or sea level depth, and with respect to the present day sea level we consider whether the sea level of any area or during any time is higher or lower. Depending on that, we introduce the term high stand and low stand. Suppose if B is the standard sea level, B point touching the standard sea level of present day, then the line above indicating the sea level is high stand sea level, that is higher elevated sea level, and the line below the this red line is indicating the low stand sea level. So with respect to the present day sea level, we consider whether my sea level is in the higher values or in the lower values. Now this thing, sub if we consider in a xy graph binary plot, so this horizontal line indicating my this horizontal line indicating my present day sea level, the above portion, the upper part indicating the positive side and the lower part indicating the negative side of sea level changes. Basically this y-axis indicating your sea level changes. So sometimes sea levels deviating from the present day situation, it goes higher, that means sea level increase with respect to the present day condition, and sometimes it goes lower with respect to the present day situation. So that means during this time sea level is gradually decrease, and this is a temporal variation that indicates that sea level change or sea level height is not constant through time. Always with time sea level or mean sea level is changing. So that is why in a simple curve, sine curve, the sea level change is depicting here. So during some time sea level increase, then goes on decreasing and goes below the present day condition, then again starts rising and goes higher with respect to the present day situation. So like this way sea level is changing through time. Now in this part indicating the high stand condition, that is this condition with respect to present day situation, and similarly this part which is indicating the below depth of mean sea level with respect to present day condition, so that is the low stand condition. So like this way the positive side indicates the high stand condition of sea level, the negative side indicates the low stand of sea level with respect to present day sea level height. Now that is the previous picture is the very simple one where we consider only the rate of increase or decrease in sea water, sea level. That is the only the rate of uh, increase of water body. Now, this water body increase in height, that can be determined, or that can be affected by two ways. If it is occur globally, that is eustatic sea level change. Suppose a major deglaciation occurred, then all the uh, glacier mass arrested in the continental part, they melted and they put their contribution to the ocean body. So naturally sea level height will increase. Similarly, if glaciation occur, then the ocean water body, when they fall uh, from the clouds by rainfall or snowfall, they are trapped in the continental landmass by glacier within the glacial body, and thereby the oceanic water body gradually decreasing. So it may happen globally, or an area can increase water content or decrease the water content depending on the local tectonic effect. Suppose in the present day Bay of Bengal, the area suffers some active faulting. So due to this faulting, the Sundarban areas goes below. That is a regional effect, that is not affected uh, that is not a global phenomena. So the Sundarban areas, as it is goes downward due to faulting, so those particular areas now feel or now suffer a higher amount of water content, higher depth of water body. That means locally or regionally, the particular area sea level is changed due to some local tectonic activity. Similarly, that area may goes up also. So tectonically, due to faulting or any other tectonic effect, a region can goes below, thereby increasing the water content of that area, or it may goes up, that is upliftment of that area, and thereby decreasing the water content of that area. So in both the cases, whether it may be eustatic change or it may be local change, we are considering only the water content of that area. Now, another factor which is very much responsible for guiding or for depicting whether an area will go to face higher amount of water content, or the water content it already has will go decrease, that is the rate of sedimentation. So if with this curve, with this base level change curve or the sea level change curve, why it is base level change curve called? Because the mean sea level is the lowest level or base level up to which erosion occurs. So that is why it is called the base level of erosion, and the curve is called base level change curve. So if with this curve we add the sedimentation factor, now in the second curve, in number 2 curve, you can see that with that sinus curve we add a fixed amount of sedimentation. We consider that the sedimentation rate is fixed through time, uh, and we plot the sedimentation rate. So you can see that here in this portion, although here water level is gradually increasing, but the area also suffers some amount of sedimentation. So due to this sedimentation, there is almost no effect. That means the sedimentation rate is almost superimposing or almost equal or higher to the amount of creation of accommodation space, that is rate of increase of water level. So that means sedimentation rate surpasses the rate of creation of accommodation space. So although my sea level is increasing, but due to higher sedimentation rate, the area suffers regression. Similarly, in this portion also, here also you can see that sea level is gradually increasing, but again there is sedimentation rate, this greenish portion, and this sedimentation rate is again surpluses the creation of accommodation space, so the area suffers regression. In this portion, that portion, whatever may be your sedimentation rate, the sea level is gradually decreasing. So this entire portion suffers regression. This entire portion suffers regression due to sea level fall. You may consider sedimentation rate or may not, whatever your sedimentation rate is there, but your overall sea level fall is the main guiding factor here. That is why naturally the area suffers low water content with respect to the previous one. So that means the area suffers regression. Now, only in this portion where the sea level is rising and that portion overcome this portion overcome the sedimentation rate. That means only in this portion the rate of creation of accommodation space, that means rate of increasing water content, is higher than sedimentation rate. So that is why only in this portion one area can suffer transgression. Except these, all other conditions within this curve, an area suffers regression. Now sometimes regression can occur due to simple base level change which is greater than the sedimentation rate, that is this portion where the sea level fall is the main cause for regression, that is called normal regression. And sometimes although sea level may increase or not, sea level might increase, but due to higher sedimentation rate than the sea level increase, the area suffers regression. So it is known as forced regression. So forced regression means, suppose your sea level increase is 1 centimeter per year. So from 2020 to 2021, your sea level of any area increased 1 centimeter. Now within this time, this entire 1 year time, there is sedimentation also from the river bodies within that coastal areas. Now if during this 1 year time your sedimentation is 2 centimeter, so what will be the net effect? Your sea level increase is 1 centimeter, but your sedimentation occurred 2 centimeter. So if we consider or compare these two things, so ultimately 1 centimeter sea level increase is nullified by 1 centimeter sedimentation, and after that remaining 1 centimeter sedimentation is excess happen during this 1 year time interval. So due to this excess 1 year time interval, that area will be in less water content, or that area suffers regression. So that is called forced regression, where although the sea level is increasing, but due to higher sedimentation rate, the area suffers regression. So you can understand that not only the sea level change is the guiding factor for transgression or regression, but along with the sea level changes, an area will suffer transgression or regression that will also depend on the sedimentation rate. So together the sedimentation rate and the rate of base level changes together, their combination decide whether an area suffers transgression, higher sea level condition, or regression, that is lower sea level condition. Now transgression happen. Now here two new terms you will face, that is retrogradation and progradation. Transgression and regression, these two terms are basically considered with respect to sea level changes. Sea level increase is called transgression, that is the amount of seawater above an area is increased, it is called transgression. Similarly, when the amount of water decrease, that is called regression. Retrogradation and progradation, these two terms are considered with respect to shoreline movement. When shoreline shifts towards land, that means more water body is there, so more land area is now inundated with that increased amount of water, then it is called retrogradation. That means your shoreline is retreating towards more land. And oppositely, during regression, my sea level falls, so more land area is exposed now. That means your shoreline is prograding, moving forward more to the basinal part, more to the deep oceanic part. So that is known as progradation. So transgression is equivalent to retrogradation, regression is equivalent to progradation. Now the timings when transgression and regression occur. Transgression occur when my rate of creation of accommodation space will be greater than sediment supply. So this is the ultimate two factors, as I previously told you, which guide transgression and similarly regression. When accommodation space is greater than sediment supply, that means the area face more water content with time, and then we call them as transgression. What about the facies? The facies, that means the depositional sediments, they will gradually shift towards landward side. So previously in this area, suppose in this area where these brownish color materials are deposited during this time, and in a more deeper part these yellowish color materials are deposited. Now with increasing water body, the shoreline is shifted more towards landward part, so this area now face this yellowish color sediments deposition, and this brownish color deposition will be occur far before than this point. So all the facies, so similar, so if this area is shallow water facies previously, now due to increase in water level condition, the area may face deeper water deposition. So all the facies will shift landward side. That means if we go up through the bed, we will get a fining upward sequence. Oppositely, in case of retrogradation, when sea level drops, that means sediment supply, that is rate of sedimentation, is far greater than the rate of creation of accommodation space, and the facies will shift seaward or towards the basinal part. Here you can see that in this area gradually more landward material is coming above this area, so all the facies will move towards seaward part. You can see these brownish color or chocolate color faces, they will move more towards the basinal part. So that is called regression or progression. Third thing, that is forced regression, where regression occur not due to the higher amount of sediment supply but due to the base level fall, that means due to the sea level fall. Here not only faces shift basinward like the conditions in regression, normal regression we found, uh, faces shift landward, but in this place, in the uh, shallower portion, in the landward portion, that these areas are now exposed for subaerial activity, so those areas suffer erosion. That means some kinds of unconformity will be found in these areas. Okay, and the last one, that is aggradation, where the rate of sedimentation is almost equivalent to the rate of creation of accommodation space. That is almost static shoreline condition. But this condition here, you can see that the point suffers almost same water depth condition through time. So same phases will occur, will one after another, above the previous timing deposition. So neither shifting of phases towards land part or basinal part can observe in this condition, and this condition is very um, short durational. That means they occur for a short duration time. They are not very prolonged phenomena. So depending on the sediment supply and accommodation space, these four conditions are found in the sedimentary rock record. Now there are some terminologies depending on those deposition formed due to aggradation, progradation, retrogradation, and forced regression. Um, Four terminologies are mainly there: on lap, down lap, top lap, and off lap. Basically these terminologies are came from the subsurface stratigraphy uh, study, that is the seismic stratigraphic study. These terminologies are came, but nowadays it is also used in sequence stratigraphic studies. So what is on lap? On lap is the when younger layers successively covering more of the underlying unit and subna is covering completely. So you can see that these layers they are covering all the previous units. The topmost layer, you can also see that it is covering all the previously lying same orientation lying units are completely covered. So this is called on lap. This boundary, basically these are the boundary conditional terminologies. Next is the off lap, where it is a pattern of stratal packages that build upwards. That means vertically the top part is also covered, as well as laterally outward parts spatially it is also covered. You can see that above this bed this strata is covering the topmost part, as well as laterally more spread. Similarly this one, similarly this one. So not only the topmost part is covered, but laterally it is spreading more area. So this is called off lap. Down lap and top lap, these are for some inclined bodies, inclined stratal packages, which makes an angle with the uh, horizontal layers found above and below. When these inclined surfaces or inclined stratas makes an angle with the bottom horizontal surfaces, then this portion is known as down left. This portion, when this inclined surface makes an angle with the upper horizontal surfaces, then this portion is known as top lap. So for terminology: on lap, off lap, down lap, and top lap. Okay, now depending on these relationship of sedimentary deposition by the sea level change, in 1963 Larry Sloss, in studying the sedimentary rocks of North America, he found that the sedimentation pattern is changing, and this changing pattern is basically occurred due to relative sea level changes. So Sloss delineated a series of sequences, a series of depositions which are deposited on the basement surface in North American Craton, they show some stratal onlap, which is basically the result of transgression, that means sea level rise. In some conditions with time, he found stratal offlap, which is basically formed due to regression. So that means the change in stratal condition or change in sedimentary condition, change in sedimentary type, sometimes it is showing on lap nature, sometimes it is showing off lap nature, and this changing pattern occurs due to sea level changes with time. If sea level remains fixed during the deposition of those stratal packages, then there will be no on lap, off lap, down lap, or top lap. That will be a fixed condition that occurs in the aggregation condition, when one after another same lithology you will find in a place. So only if the sea level of an area is changing with time, then only you found variation in sedimentary deposition in that area. So that means my sedimentation change of an area is occurs due to transgression or regression, that means due to sea level changes. This kind of analysis of stratigraphic approach in stratigraphic study of an area, which is basically genetically, that means by their genesis, how they origin related with the sea level change, these kind of studies are known as sequence stratigraphy. So Larry Sloss is the first pioneer worker who identified that sedimentation record is changing with respect to the sea level changes. Now, this tracks. So, four kinds of system tracks are identified or recognized depending on the sea level conditions. These are known as high stand system tract, falling stage system tract, low stand system tract, and transgressive system tract. So from starting from one sea level fall to the next sea level fall, there are four kinds of system tracts recognized in the sedimentary rock record. I'll come one by. So start with the low stand system tract. Here you can see a sea level curve, a sine curve of relative sea level. Low stand system tract is the lowermost position. It includes the deposition that occur uh, after a relative, uh, that means that occur before a relative sea level rise, that is after a rapid regression. So this red area indicates a rapid sea level fall, and after this rapid regression, when the sea level condition, uh, that means rate of increase in base level and sedimentation supply is almost same, this portion uh, where almost same, this condition is known as low stand system tract. So this low stand system tract, here the sedimentation found is either aggradational or progradational. Okay. And the end of this low stand system tract is marks the beginning of transgression. So that portion, this uh, end marks the begin of another kind of system tract. So low stand sediments tract, sediments fill or partially infill the incised valleys, because this area in this red portion where a rapid regression occurs, that means the areas are exposed now to subaerial activity. So due to the subaerial activity, as I already told you, that area may suffer erosion. So due to erosions, there are lots of depressions or erosional features you may find. Now during this low stand area, low stand condition, sorry, during this low stand condition, where the rate of creation of accommodation space and um, sediment supply is more or less equal. So during this time, these erosional features of the previous system tract, this red portion, they are filled up or they are healed by in during this low stand condition. Second is the transgressive system tract, the bluish portion. So you can see the lower portion um marks the end of the LST, low stand system tract. Okay, so it comprises deposits that accumulate or that form during an active transgression when rate of creation of accommodation space is much higher than the sediment supply, and it ends just prior to a new regression or HST, high stand system tract. Here this yellowish portion is the indicating the high stand system tract. So the TST or transgressive system tract is bounded at the lower part by LST and bounded in the upper part by HST. So this uh, surface or this portion where TST is separated from HST, that marks the maximum landward shifting of the shoreline. So this is often known as maximum flooding surface, MFS, maximum flooding surface. Now it comes to your mind that after that point my sea level is also increasing. So why this is called maximum flooding surface? If sea level is increasing, then also my shoreline will shift more towards landward part. So why MFS is there, not here? Because in this yellowish portion, as I already told you, the curve becomes more gentler. So in this portion, my rate of accommodation space and my rate of sediment supply is almost equal, or sometimes the rate of sediment supply surpasses the rate of creation of accommodation space. So although sea level is increasing, but due to higher amount of sediment supply, this area either deposition is aggradational or progradational. So my shoreline remains either static or shoreline starts moving towards basinal part, that is more towards seaward part. So this is the maximum limit of shoreline movement towards the land part. That is why it is known as maximum flooding surface. That means maximum transgression surface or transgression occur up to the maximum this limit in the landward side. Similarly, the point from where transgression starts, that means the end of LST and start of TST, this surface is known as transgressive surface. Transgressive surface, then it indicates the starting point of transgressive system tract. So the starting point of transgressive system tract is marked by the end of LST, that is the transgressive surface, and the end of transgressive system tract is marked by the maximum flooding surface formed when marine sediments reach their most landward position. Next is the HST, this yellowish portion, this upper part. As I already told you, here my rate of creation of accommodation space is overwhelmed by the sedimentation rate. That means sedimentation rate is almost equal or higher than the accommodation space. So the sedimentation is almost aggradational or um, regression, that is progressional sedimentation starts. um, this portion is known as high stand system tract. So all here, although the sea level is high, sea level is reaching its maximum landward uh, point or maximum landward boundary during this maximum flooding surface time during HST. Here the sea level is actually high, but due to the increased amount of sedimentation, the area suffers either aggradation or progradation. So that is known as the high stand system tract. Next is the falling stage system tract, that is the regression due to sea level fall. So this is the red portion where sedimentation have very least effect for regression. Here the sea level depth or sea level height is decreasing. So whatever may be the sedimentation amount, whatever may be the sedimentation rate, due to the uh, falling condition of relative sea level, in this portion regression is found to occur, and this system tract is known as falling stage system tract, that is formed due to forced regression. As I already previously told you, that forced regression is when sea level fall, what sea level normally fall, whatever may be your sedimentation rate. Okay. So this falling stage system tract is bounded in its upper part by HST, this yellowish portion, and in its lower part by LST, this greenish portion. Now a special terminology, that is the maximum flooding surface, what I already told you, that is occur between TST, this bluish portion, and HST, this yellowish portion. It represent by a change from retrogradation, that means transgression, to aggradation or progression, that means regression or aggradation. So here transgression is occur, transgression goes to its reach to its peak here. In this condition transgression is peak, then after that either aggradation or progradation will occur. The surface or the deposition during this condition is very thin succession, thin deposition characterized by very slow rate of sedimentation, as during this time my rate of creation of accommodation space is almost equal to the sediment supply. So basically the basin is almost starved with sediment, that means no sedimentation or very little sedimentation occurred during this time for a uh, periodically long time. So the deposition found during this time is known as condensed zone. Okay, so within a very thin sedimentary package, relatively large time span covering sedimentation is found during the deposition in MFS. So that is how MFS is identified in rock record. Okay, so this zone is known as condensed zone. So from our previous discussions, we are known about the defined system tracks. This is HST, then FSST, falling stage system track, then LST, and then TST up to the onset of HST. So if with this sea level change curve, we can see the sedimentation change, nature of sedimentary rock record change. We can see that sometimes if these are my sedimentary record from shallow marine to deep marine, so if this direction is my basinal direction, that is the deep marine direction, so we can see that sometimes the uh, deep marine depositional conditions, they will move towards the shallower part. That will happen during a transgression time. So this indicates that this movement of during this time, the movement of sedimentary record towards the landward part is formed due to transgression, and that is why all the faces they shifted towards landward part. That means these are the results of TST, and in this part you can see that the faces are shifting more towards the basinal part. So this means that it is results from mainly uh, falling stage system tract, that is FSST, and within between these two LST and HST are found to occur. So due to sea level increase, my facies will shift towards landward part, shoreline shift more towards land part. Due to regression, my shoreline will shift more towards the seaward part or more towards the deep marine part. So my sedimentation pattern or litho boundaries will form this zigzag pattern with changing sea level condition. So this part, so this is the end of falling stage system tract, one falling stage system tract, and previously this one the end of one falling stage system tract. So this entire deposition is known as one sequence of deposition. That means starting from here, end of falling stage system tract, and next when the curve is goes on increasing, uh, this. So from here to here, from end of falling stage system tract, from end of regression to another end of sea level fall, another end of regression, this entire deposition is known as sequence. And within this sequence there are various system tracts, as we came to previously. Okay, so basically these two boundaries, the top boundary and lowermost boundary, as these are indicative of falling system tract, when sea level normally falls, whatever may be the sedimentation amount, due to the higher rate of sea level fall, the area is exposed to subaerial activity, so some kinds of disconformity surfaces or unconformity surfaces are found at the top and bottom of the sequence. So a sequence is bounded by the by some kinds of unconformity surfaces at its top and bottom. A depositional sequence is a stratigraphic unit bounded at its top and base by unconformities, as I already told, or they are correlative conformities. Correlative conformities means the unconformities found in the shallower part of the basin where it is exposed to subaerial activity. Now, during the same tiny interval in the deeper part of the basin, there we found some amount of deposition or simply non-deposition, which is equivalent with in time with this unconformity surface. So that is why, as there is no unconformities, no gap in sedimentation, so that is why the deep equivalent surface of the unconformity surface formed in the shallower part, the equivalent surface in the deeper water part is known as correlative conformity, and that may be a non-depositional surface or a depositional unit in the deeper basin part. So unconformity occur in the shallower part. Correlative conformity, this term is for the deeper basinal part. So you can see that how the sea level changes with time in this curve, and within the sea level changes there are different system tract. You can see falling stage system tract, low stand system tract, TST, HST. So all these system tracts are found. Now, generally, when you consider a sequence or when you studies the system tract with respect to a sequence, then the sea level changes curved is considered is above 10 million years scale. I previously told you in your previous class about the bell curve where you can see or you will find different order of sea level changes. So when you consider sequences or different system tract, the sea level change occurs in above 10 million year condition, but below 10 million year time span, the sea level change is also happening there. So within this larger sea level change condition, there are numerous small scale sea level changing conditions. So you can see that sea level is goes up and down. Although the overall sequence, overall sea level is gradually increasing. Similarly, in this case, in falling stage system track, although overall the sea level is decreasing, but within this decreasing trend, there are numerous up and down cycles, and that is below 10 million year cycle. So these are known as parasequences, which is bounded by marine flooding surfaces. That means if I consider this curve here, the maximum flooding occur similar to the marine flooding surface of the sequence. In smaller case, in smaller scale, smaller order of sea level change, it is known as marine flooding surface. So one marine flooding surface to one marine flooding surface. Mind it, a sequence is bounded by unconformities, but a parasequence is a minute part of an sequence, which is a conformable succession and genetically related beds bounded by marine flooding surfaces. Okay, so this top person, another marine flooding surface, another marine flooding surface. So these are one. This is one parasequence. This is one parasequence. This is one parasequence. So like this, a sequence consists of many parasequences. Okay, and they are bounded in its top and bottom by the marine flooding surfaces. So that's all. That's the brief introduction about sequence stratigraphy. Hope uh, it will help you understanding the basic things of sequence stratigraphy. Thank you.